improper grounding or bonding of the electrical service can lead to excessive voltage during fault currents and lightning strikes, potentially damaging equipment. Lightning strikes can induce high voltage surges on electrical lines, even without a direct hit, and these surges can travel through the electrical system. Faulty or undersized surge protectors may not effectively divert excess voltage to ground. An overloaded circuit could trip the breaker and cause a power surge upon reset. To troubleshoot, firstly, check grounding and bonding to verify they meet local electrical codes. Secondly, install surge protectors for all sensitive electronic equipment with appropriate ratings. Thirdly, check circuit load to determine if it was overloaded, redistribute the load, or upgrade the circuit capacity. Fourthly, inspect damaged equipment for visible damage and test functionality if possible. Fifthly, contact a qualified electrician for further investigation if the problem persists. Homeowners should purchase surge protectors for valuable electronics. Unplug sensitive electronics during severe weather. Consider a whole house surge protector at the main electrical panel. Ensure regular electrical system inspections and maintenance by a qualified electrician. Lightning strikes are unpredictable, even with proper grounding and surge protection. Homeowners should consider insurance coverage for electronics against lightning damage. For a deeper dive into electrical grounding and bonding, let's explore the concepts more thoroughly. Grounding provides a path for fault current to return to the source, allowing the overcurrent protective device, such as a circuit breaker, to trip and energize the circuit. Bonding ensures that all metallic parts of the electrical system are at the same potential, minimizing the risk of electric shock. A proper grounding can manifest in several ways, including elevated neutral to ground voltage, which can cause electronic equipment to malfunction or be damaged. Common causes of improper grounding include loose connections, corroded grounding electrodes, and undersized grounding conductors. Bonding issues can arise from loose or missing bonding jumpers, especially at metallic enclosures or pipes. To verify proper grounding and bonding, you'll need to use a multimeter to measure the resistance between the grounding electrode and the neutral conductor. The resistance should be as low as possible, ideally less than 1 ohm. Also, check the voltage between the neutral and ground conductors. It should be close to 0 volts. If you find high resistance or voltage, inspect all grounding and bonding connections for looseness or corrosion. Tighten or replace any faulty connections. The grounding electrode system typically consists of a ground rod, ground plate, or metal underground water pipe. The grounding electrode conductor connects the grounding electrode to the neutral bus in the service panel. The size of the grounding electrode conductor is determined by the size of the service entrance conductors, as specified in the National Electrical Code, or NEC, Table 250.66. Bonding jumpers are used to connect metallic enclosures, such as service panels, junction boxes, and equipment housings to the grounding system. The size of the bonding jumpers is determined by the size of the circuit conductors, as specified in NEC Table 250.102. Let's delve into surge protection. Surge protectors work by diverting excess voltage to ground, preventing it from reaching sensitive electronic equipment. There are two main types of surge protectors: point-of-view surge protectors and whole-house surge protectors. Point-of-view surge protectors are typically power strips with built-in surge protection. They are designed to protect individual electronic devices, such as computers, televisions, and stereos. Whole-house surge protectors are installed at the main electrical panel and protect the entire electrical system from surges. They are more expensive than point-of-view surge protectors, but they provide broader protection. Surge protectors are rated by their surge current capacity, which is the maximum amount of current they can divert to ground. A higher surge current capacity indicates better protection. It is recommended to choose surge protectors with a surge current capacity of at least 40,000 amps. Surge protectors also have a voltage protection rating, which indicates the maximum voltage that will be allowed to pass through to the protected equipment. A low voltage protection rating indicates better protection. Look for surge protectors with a voltage protection rating of 330 volts or less. It is important to note that surge protectors have a limited lifespan. They can degrade over time due to repeated surges. It is recommended to replace surge protectors every 2 years or after a major surge event, such as a lightning strike. Now, consider circuit load and potential overload. An overloaded circuit can cause the circuit breaker to trip, interrupting power to the circuit. This can happen if too many devices are plugged into the circuit at the same time, exceeding the circuit's ampacity rating. Circuit breakers are designed to protect the circuit from overload by tripping when the current exceeds the breaker's rating. Common causes of overloaded circuits include using too many high-wattage appliances on the same circuit, such as space heaters, hair dryers, and microwave ovens. Another cause of overloaded circuits is using extension cords improperly. Extension cords can overheat if they are not rated for the amount of current being drawn through them. To determine if a circuit is overloaded, you can use an ammeter to measure the current flowing through the circuit. The current should not exceed 80% of the circuit breaker's rating. For example, a 15 amp circuit breaker should not have more than 12 amps flowing through it. If you find that a circuit is overloaded, you can redistribute the load by moving some of the devices to another circuit. You can also upgrade the circuit capacity by replacing the circuit breaker with a higher amperage breaker. However, you should only do this if the wiring is also rated for the higher amperage. It is important to consult with a qualified electrician before upgrading a circuit breaker. Let's touch upon electrical safety in general. Electrical safety is paramount in any home. Firstly, always turn off the power at the circuit breaker before working on any electrical circuits or equipment. Secondly, use properly insulated tools and equipment when working with electricity. Thirdly, never work on electrical circuits or equipment when you are wet or standing in water. Fourthly, inspect electrical cords and plugs regularly for damage. Replace any damaged cords or plugs immediately. Fifthly, never overload electrical outlets or extension cords. Sixthly, install ground fault circuit interrupters, or GFCIs, in areas where water is present, such as bathrooms, kitchens, and outdoor outlets. GFCIs are designed to protect against electric shock by tripping when they detect a ground fault. Seventhly, have your electrical system inspected regularly by a qualified electrician. This will help identify any potential hazards and ensure that your electrical system is safe and up to code. When dealing with damaged equipment, it is important to proceed with caution. Damaged electronic equipment can pose a fire hazard or an electric shock hazard. Firstly, unplug the damaged equipment immediately. Secondly, inspect the equipment for visible damage, such as burnt wires, melted components, or cracked housings. Thirdly, do not attempt to repair the equipment yourself unless you are qualified to do so. Fourthly, dispose of the damaged equipment properly. Electronic equipment should be recycled whenever possible. If you are not sure how to dispose of the equipment properly, contact your local waste management authority. In the aftermath of a lightning strike, a comprehensive inspection of the electrical system is crucial. This inspection should include checking for damaged wiring, loose connections, and damaged components. Pay close attention to the service panel as it is the central hub of the electrical system. Look for signs of arcing, burning, or corrosion. Also, check the surge protectors to see if they have been damaged. Surge protectors typically have an indicator light that shows whether they are still functioning properly. If the indicator light is off, the surge protector needs to be replaced. It is also important to check the grounding system to ensure that it is still intact. Lightning strikes can damage the grounding electrode or the grounding electrode conductor. If you suspect that the grounding system has been damaged, contact a qualified electrician to inspect it. Additional considerations include understanding lightning protection systems. Lightning protection systems are designed to protect buildings from direct lightning strikes. They consist of air terminals, down conductors, and grounding electrodes. Air terminals are installed on the roof of the building and are designed to intercept lightning strikes. Down conductors are used to carry the lightning current from the air terminals to the grounding electrodes. Grounding electrodes are buried in the ground and are designed to dissipate the lightning current safely. Lightning protection systems are typically installed on tall buildings such as skyscrapers and churches. However, they can also be installed on homes and other buildings. If you live in an area that is prone to lightning strikes, you may want to consider installing a lightning protection system. It's important to understand insurance coverage. Homeowners insurance policies typically cover damage caused by lightning strikes. However, it is important to review your policy to understand the specific coverage and limitations. Some policies may have exclusions for certain types of damage, such as damage to electronic equipment. It is also important to keep an inventory of your electronic equipment, including the make, model, and purchase price. This will make it easier to file a claim if your equipment is damaged by lightning. In conclusion, addressing electrical issues, especially those related to lightning strikes, requires a systematic approach involving inspection, troubleshooting, and the implementation of protective measures. Proper grounding and bonding, surge protection, and adherence to electrical safety practices are essential for protecting your home and electronic equipment from damage. Consulting with a qualified electrician is crucial for ensuring the safety and integrity of your electrical system. Remember that the information presented here is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician before undertaking any electrical work.